Hi children, in the first class we discussed about the reflection of light. Reflection is the bending, it is a coming back of light from a smooth and shiny surface, or it is a sending back of light from a smooth and shiny surface. And best example for this smooth and shiny surface is nothing but mirror. So mirrors are very good reflectors of light. And today we are going to discuss what are the two conditions to satisfy to get a reflection of light. So when a light is reflecting, what are the two conditions for the reflection? Okay children, look at the board. This is the pictorial representation of a mirror. So mirror is having two faces. First face is the reflecting side, and back of the mirror is not a reflecting side, though the mirror is made of a transparent material, glass, but only one face is the active face, or the back side of the mirror is not active. This is non-reflecting side. Back side is non-reflecting side and front side is the reflecting side of the mirror. So we see our image on the reflecting side, not on the the reflection takes place at the reflecting side, not on back side of the mirror. And in this way we can pictorially represent a mirror. Here the back is a non-reflecting side and front side is the reflecting side of the mirror. So pictorial, this is the pictorial representation of a mirror. And what are the two possible conditions to reflect the light ray? Light always travels in the form of a wave, and we can represent a light in the form of straight lines. So if a ray is coming from a sun, so we can write this is a ray coming from sun. So suppose this is the sun, position of the sun. This is a single ray coming out from sun. So we can, like this, we can represent wave with a straight line having an arrowhead. This is the arrowhead. So arrowhead shows the direction in which the ray is moving. If a ray is moving from left to right, this is the pictorial representation of a ray. If a ray is from right to left, in this way we draw the ray. If a ray is from down to up, this is the representation of the ray. A ray can be represented by using two things. One is a straight line, and the straight line shows the presence of a ray, and the arrowhead points the direction of the ray. So in this manner, this is from right to left, this is from left to right, this is from down to top, and this is straightly from sun. This is the direction of motion of the ray. So same way here a mirror is placed, so we can draw a line or we can draw a ray. So this is a ray. What is the direction? This is the direction of the ray. A ray is coming from the top and it strikes the mirror at this particular point. So we can name the ray. AB is a ray, that is an incident ray that strikes the mirror at the point O. O is the point of intersection of this ray on the mirror. So O is the point of incidence. And AB is a ray. This is moving from A to B. This is the direction of movement. And this is the point of intersection, or the point at which the ray strikes the mirror. And what happens to this mirror, this ray? The incident ray strikes the mirror. This is a smooth and shiny surface. What will happen? The ray will get reflected. The ray will get reflected along another direction. So this is the direction of the reflected ray. So this is incident ray. This is the reflected ray. And if you want to study about the laws of reflection, we should draw a line exactly at the point of incidence. So we should draw a line starting from the point of incidence. So this is the ray, not a ray, it is a single line using dotted. This is a dotted line. Dotted line shows that this is the normal drawn at the point of incidence O. So we can name all the things here in the diagram. AB is an incident ray, BC is a reflected ray, and O' O is the line drawn at the point of incidence O. So these are the three important rays or three important lines in this diagram. Okay, incident ray, reflected ray. This is not a ray. Center line is a dotted line. That is not a ray. That shows a perpendicular drawn at the point of incidence. Okay, and here if a light ray, this ray has to suffer the process of reflection whenever the angle, these two angles are equal. These two angles are equal. What is this angle? This is the angle made by incident ray and the normal. This is called the angle of incidence. I is the letter used to denote angle of incidence. I, angle of incidence. Then this is the angle made by reflected ray and the normal. This is another angle. So we call that as angle R. That is the angle of reflection. So these two are the two important angles here in this diagram. So angle made by incident ray AB with the normal, that is angle of incidence, this angle, and the angle made by the reflected ray and the normal is called angle R. These two are the different angles. Okay, angle of incidence and angle of reflection. And in the case of reflection, these two angles are equal. I is always equal to R, or angle I is equal to angle R, or the angle of incidence is equal to angle of reflection. That means that the angle made by the normal and the incident ray is always equal to the angle made by reflected ray and the normal. For example, if I is equal to 45 degree, what will be the value of R? That is also 45 degree. If the angle I is equal to 45 degree or 55 degree, then angle R also will be equal to 55. If 60 degree is the angle of incidence, angle of reflection is also equal to 60. If angle of incidence is 0 degree, then angle of reflection is also equal to 0 degree. Clear? So that is the angle of incidence and angle of reflection. That is the first law of law of reflection. According to the law of reflection, the angle of incidence is always equal to angle of reflection. So whatever be the angle made by incident ray with the normal drawn at that point, that will be equal to the angle made by the reflected ray and the same normal. Okay, so I is equal to R. That is the first law of reflection. That is, angle of incidence is always equal to angle of reflection. And second one, these three important lines in the sense, first is a ray, AB is a ray, incident ray. Then second line is the reflected ray, that is also another ray. In the diagram, that is a ray. And the center line, that is a normal drawn, that is actually a line. It is not a ray. And these three must lie on the same plane. Here in this figure, AB, then C, what is this? BC and OO dash, these three are lying on the same plane of this board. So that is the second condition. Okay, these all the things, that is incident ray, then reflected ray and the normal, all these three lines must be on a single plane or on the same plane. The angle made is in this plane. R is also existing in the same plane. Then the angle normal drawn is also on the same plane. So these three are lying on the same plane. So that is the second law of reflection. Okay, children. So we discussed the two laws. Whenever these two laws are satisfying, that ray has to suffer the process of reflection. Whenever these two conditions are satisfying by a light ray, that light ray must undergo the process of reflection. What are the conditions? The angle of incidence must be equal to angle of reflection. Then incident ray, reflected ray and the normal, these three must lie on the same plane. Here in the figure you can see these three things are on the same plane of this blackboard. Okay, if the reflected ray is on the other side, we will say that is on the other plane. But these three are lying on the same area. That is the meaning. same field or same place. So that is the second condition of reflection. So these two are the two very important statements or two important laws. So first law, what is the first law? According to the first law of reflection, the angle made by incident ray and the normal is equal to the angle made by reflected ray with the normal, or angle I is always equal to angle R. Then second one, the incident ray, the reflected ray and the normal line drawn at the point. This is not a ray. So you should be very careful when writing the second law. The angle of the incident ray, reflected ray and the normal is not a ray. Normal is a line drawn there. These three things must lie on the same plane. Okay, so these two are the two important laws of reflection. Whenever a ray is satisfying these two conditions, that ray will undergo definitely the process of reflection. Okay, so with this we completed what are the two laws of reflection. And with one more main content, we will wind up today's class. And let me check that what are the different. And now we discuss what are the different nature of the image formed by a plane mirror. You all are familiar with the image formed by a plane mirror. When you look at when you stand in front of a mirror, you can see the image behind the mirror. Am I right? When you stand in front of the mirror, you will see your face behind the mirror. Okay. So the position of the image is, you are the object standing in front. Position of the image is back of the mirror. Okay. So all will get the image. So whatever we place in front of a mirror, the image of that object will be formed behind it. Okay. And when you are standing in front, you will see your face behind the mirror. And if you move backward, the image will also move backward. If you move forward to the mirror, the image will also shift accordingly. Okay. And now we discuss what are the different characteristics of image formed in a plane mirror. Okay, this is plane mirror. So what are the different characteristics of image formed, or what is the nature of the image formed by a plane mirror? So listen, first point is, the image formed by a plane mirror is not a real image. So no such real image behind the mirror. It is not possible. Okay. So in image is formed, that image is a virtual image. That is not really existing. No such image. It is just an illusion. When we look at the mirror, we see a duplicate of your face behind the mirror, but it is not a real one. Okay, it is not a real one. Because no light can reach back of the mirror. Okay, so there won't be any image, but when we look at the mirror, we see the duplicate of your face behind it. It is not a real one. We call it as a virtual one. Okay, and it is always with the correct side, correct image. Erect image means it is a correct one. Correct one in the sense, top of your face will be top of the image. The bottom of your face will be in the bottom of your image, or it is an upright image. Okay, that will give always an erect image, not upside down. Okay, top will remain as the top of the image and bottom of the object will remain as the bottom of the object. Okay, and this is not inverted. Inverted means top will come as the bottom of the object will come as the top of the image. Not like that. It is an erect image. That is the second characteristic. Third one. So the plane mirror always form a virtual image. That is always erect one. Virtual means not real. Erect means correct side up. Not upside down. Correct side up. So we call that as erect image. And we can see that the distance between object and the mirror is always equal to the distance between mirror and the image. The distance between or gap between you are the image, you and the mirror is always equal to the distance between your image and the mirror. So distance between object, that is your face in front of the mirror, that is object. Object and the mirror is always equal to the distance between image formed behind the mirror and the mirror. Okay, so that is the third characteristic of image formed. Or we say the distance between object and the mirror is always denoted by the letter V. No, not V, U. U is the letter used to denote the distance between object and, what is the object? Your face is the object. Okay, you are standing in front of the mirror, you are acting as the object here. So distance between your face and the mirror is equal to the distance between the image formed behind the mirror and the mirror. Okay, so U is always equal to V. Suppose you are standing at a distance 1 meter from the mirror, 1 meter in the front of the mirror. The image formed will be 1 meter behind the mirror. If you are standing at a place 50 centimeter from the mirror, the image will also at a distance of 50 centimeter to the back of the mirror. If you are standing at a distance of 1 meter to the front of the mirror, then image will also at a distance 1 meter away from the mirror. So that is the meaning of the third point. And fourth point, then height of the image, height of the object is equal to height of the image. Height is also equal. Image height is equal to object height. So whatever be the height of your height of you, and that will be the same, the image will also have the same height. So that is the fourth point. And fifth point, it is laterally inversed. Laterally inversed. And what is the meaning of the word laterally inversed image? Laterally means when you raise the left hand inside the mirror, left hand in the image, that will be the right hand. When you raise the right hand, that will be in the that will be the children. Now you what you see on this, what you see here is my image. Okay, and the image is a virtual one because the image is formed behind this mirror. This is the mirror, image is formed behind it. So it is not possible. So I call my image as a virtual image. And it is erect one. My top is the top of the image. My bottom is the bottom of the image. So that is an erect one. Okay. And distance or gap between me and the image mirror is equal to the distance between my image and the mirror. That is the third point. And fourth point, the height. This is the height of the object and the image is also having same height. Okay. And the last point is the lateral inversion. When I raise this is my right hand. Right hand, for the image it is the left hand. When I raise the left hand, for the image it is the right. So left of the object will come as the right of the image and right of the object will come as the left of the image. That is called the lateral inversion. Okay. Left will come as the right in the image and right of the object will come as the left of the image. That is lateral inversion. So these are the different properties of the image formed by a plane mirror. First point, it is always virtual. Virtual meaning is not really existing. Second one, it is always erect. Meaning is top remains as the top of the object and bottom of the object remains as the bottom of the image. And third one, the gap between mirror and the image is equal to the gap between the object and the image and the mirror. Then it is the height remains as the same. Height of the object is equal to the height of the image. And last point is it is laterally inversed. So these are the important characteristics of a mirror. Okay, this is a plane mirror. This is the reflecting side of the plane mirror. And back of the mirror you can't see, I can't see, but it is painted and thereby we are blocking the passage of the light through this transparent material. So mirror is having only one face. This is the reflecting side of the mirror. Back of the mirror is, we can't see, it is painted or silvered and painted from back side. So no light ray can pass through it, but instead of that, all the light rays are reflecting back and converging and producing an image at the back of the mirror. So with this, we completed all the characteristics of image, and see you in the next class with the next topic. Thank you. Thank you, children.